picking up good vibrations.
Now we'll talk about signal transformations. These transformations are important per se, but they will also allow us later on to define more elaborate transformations such as the Fourier transform. Now, given a signal x, if you have a signal x, if we consider the signal x of minus t, this corresponds to a reflection with respect to the signal axis. The signal x of t plus delta corresponds to a shifting of the signal. Now, if delta is negative, the signal will actually shift to the right. If delta is positive, it will shift to the left. The signal x of at, the transformation of the independent variable t, will be a shrinked version of the original signal if a is larger than 1, and it will be a stretched version of the original signal if a is less than 1. This is often counterintuitive, but for instance, think about sine of t and sine of 2 pi times t. Sine of t has period 2 pi, and sine of 2 pi times t has period 1. So it has shrinked, and 2 pi is larger than 1. Another basic transformation is to shrink or stretch a signal in the signal axis, and this is just obtained by multiplying by a constant a. If a is larger than 1, we get stretching. If a is less than 1, we get shrinking. Now, all the transformations that I've talked so far, we can always reverse them. In discrete time is a little bit more subtle. Two transformations are still very easy: the reflection and the scaling in the signal axis. If you have a signal in discrete time, and if we reflect it around the signal axis, we get x minus n. Scaling is also very easy in the independent axis. If we multiply x of n with a, we either stretch it or shrink it in the signal axis. However, the two other properties that I mentioned, shifting and time axis scaling, are a bit more tricky. Shifting is still easy in the sense that we can consider the signal x of n plus delta, but now delta must be an integer. We cannot, for instance, consider x of n plus 0.5 anymore, because we don't know, for instance, when n equals 0, we don't know what is the value of x of 0.5. Time axis scaling is even a bit more trickier. Again, we cannot consider x of 0.5n. We can only consider x of an integer times n, and that integer now has to be larger than 1. However, let's say that we consider x of n 2 times n. We are only going to obtain values such as x of 2, x of 4, x of 6, etc. Therefore, we're going to lose some information, namely x of 1, x of 3, x of 5 in the transformed signal. So we cannot reverse this transformation. This transformation is also called subsampling.